Hello, welcome to this video where we're going to solve more complex radical equations. This is part 2 in a series of solving radical, specifically square root equation videos. So if you missed the first part, go back and watch that. Today we're going to look at more complex square root equations. Okay, that is our learning target. You know you're successful in this if you can first identify what a square root equation is. That's very important because we're going to start to mix together different types of radical equations as well. Now, you're also successful if you can use reverse order of operations in order to solve a square root. And you can recognize and solve a quadratic equation. This is very, very important. Next, lastly, you can determine if your solution is valid or extraneous by plugging it back in and checking. For prior knowledge, we really want to go ahead and look at this equation, and it's important that you can look at this equation and that you can notice that this is quadratic. Very, very important that you know that this is quadratic, specifically because it has an x squared. So how we solve this is we go ahead and factor. So I want factors of -5, right? My c value. What factors of -5, AC is -5, equal our b value, which is -4. And that's going to be a -5 and a +1. Okay, so there's my factorization, and that just means x minus 5 is equal to 0, or x plus 1 is equal to 0. And if I go ahead and solve this, we get x is equal to 5, or x is equal to -1. Okay, so just a refresher on solving a quadratic equation. That's going to be important in today's lesson. And then here's another practice one. You can pause me really quickly. I'll show you the answers just so you get some practice in this area. All right, hopefully you tried this one. Here's the solution. You factor that one, x minus 4, x minus 2, and that solution gave you a +4 and a +2. Okay, so without further ado, we're going to go ahead and go back over what a radical equation is. It's just simply an equation that has a variable within a radical, also known as a square root or a cube root symbol. Okay, now it can appear too as in parentheses raised to a power of a rational exponent or a fractional exponent. That's also a radical equation, but we won't focus on these in these videos. Okay. Some non-examples, these are not radical equations. We don't have an equal sign. Here I don't have a square root symbol. And then again here, no equal signs. Our steps in order to solve a square root equation are the same as previously. Step 1 and 2, you're really isolating the square root or the cube root symbol. This is isolate the square root. So step 1 and 2, sometimes you have one of them, sometimes you have none of them, sometimes you have both of them. Okay, and this is just really order of operations in reverse. Next, you'll go ahead and solve the square root by squaring both sides. You undo the square root. The inverse of square root is a square. So we're going to take that at both sides. We'll solve a resulting equation. We'll do it differently if it's linear versus quadratic, and then we'll check for extraneous solutions by plugging our answers back into the left side of the equation to see if the left side is indeed fact equal to the right side. Now, also not in this lesson, but we'll see this in the cube root, solving cube root equations, where we get imaginary solutions. Those are also deemed extraneous. Here's our first example. Please go ahead and write this one down. We want to solve the equation. Again, step number 1/2 is to isolate the radical. So I want to isolate the square root here, and I just like to highlight it, or I have my students put a box around it, just so I know, hey, this has to be by itself before I take a square root. So step 1 is undo addition subtraction. I can go ahead and subtract 8 on both sides, giving us 2 square root of 3x plus 4 is equal to -8. And then we'll go ahead and get rid of that 2 by dividing by 2 on each side, right? So those cancel, and we get square root of 3x plus 4 is equal to -4. Okay, so that was the first step, and then in the notes they call it step 3, but really I'm going to square both sides here. So square both sides. I have my square root by itself. Now I can take a square. So I'm going to square both sides of this, and we get 3x plus 4 because the square and the square root cancel. They're inverses. They undo each other, just like addition with subtraction. And then we have negative 4 squared gives us a positive 16. Okay, at this stage, I'm just going to go ahead and solve this. So note, this is a linear equation. Linear, I'm just going to put variables on one side, numbers on the other. So we'll shift the 4 over here, and we get 3x is equal to 12. We'll go ahead and isolate our variable, dividing by 3, and we get x is equal to 4. Now this is a possible solution. 4 is our possible solution. I have to check it. I have to make sure, hey, nothing funny goes on, right? So this is step 5 over here where we are checking. So we have 2 square root of 3 times, in this case, here's our answer, 4 plus 4, and then on the outside plus 8. And I want to say, okay, what does this equal? I want to make sure that it equals 0. So I'm checking, I'm plugging this in. Underneath the square root, we have 3 times 4. I know that that's 12. Plus 4 gives us 16. So 2 root 16 plus 8, that's 2 times 4 plus 8. We get 8 plus 8 is 16. So does 16 equal 0? No, it does not. So this is extraneous. Throw that out, and our answer is no solution. No solution. Didn't work. Here's the next example. Please go ahead and write this one down. Okay, so step 1, isolate that square root. Isolate that radical. So there it is. I'm going to get that by itself. I'm going to go ahead and first undo addition, subtraction. Minus 19 on both sides. These cancel. And we get negative 3 square root of 3x minus 2 is equal to negative 15. And then we'll divide by negative 3. These cancel. And we get square root of 3x minus 2 is equal to 5. Now, sometimes my students are confused. I don't know if I undo the addition first, if I subtract first, or do I divide first? What do I do? It's reverse order of operations, right? So order of operations is please excuse my dear Aunt Sally, right? PEMDAS, you work in that way. You use this when you are calculate, or checking. Okay, you're going to use reverse order. I call it SADMEP. SADMEP. One of my students coined it. And you use this when you're solving or isolating a variable. So you undo the addition subtraction first. That's what the S and the A stand for. And then you're going to undo the multiplication or division. So I have this. Next, we'll go ahead and square both sides. Squaring both sides. And we get 3x minus 2 is equal to 25. Okay, I'm going to go ahead and solve this now. I'll add 2 to both sides. We get 3x is equal to 27. And then divide by 3 on both sides. We get x is equal to 9. So this is a possible solution. Our possible solution. We're going to check this one. See if it works. So I'll check over here. I'm going to plug it back into my original equation. We have negative 3 times the square root of 3 times x. In this case, our x is 9 minus 2 plus 19. Okay, what does this equal? Does it equal 4? Okay, I'm going to check inside of here. 3 times 9, that's 27. Take away 2 is 25. So negative 3 times the square root of 25. And this gives us negative 3 times 5, which is negative 15. Okay, so what's negative 15 plus 19? That's 4. Did it equal the right side? Yep, the right side is 4. So this answer is valid. And there's our answer. Okay, going back over the steps. Isolate the radical expression, square both sides, solve it, and then we have to check, make sure it is valid. Here is a practice problem just to check your understanding. Please pause this, try this one, get some feedback on the steps, see if you got the right answer, and if you didn't, where did you get tripped up? What mistake did you make that you need to fix for your understanding? So pause me, I'll show you the answer. Okay, here is the answer. Hopefully you tried this one. You should have subtracted 1 first and then divided by 3. That would have given you square root of 2x minus 1 equals 3. You square both sides to give you 2x minus 1 equals 9, and then solving gives you x equals 5. This is the possible solution. Did you get x equals 5? You check it, you plug it into the left side. 2 times 5 is 10, take away 1 is 9, square root of 9 is 3, so 3 times 3 gives us 9, plus 1, 10. That equals the right side. Hooray! We did it. Here is another practice one. So again, pause me, try this example, especially if you got that last one wrong. Try this one, fix your errors, and I'll show you the answers in a second. Okay, hopefully you try this one. Here is the solution. You should have gotten no solution. Your possible answer was 29. So we take away 20, we'll divide by 4 to give us negative 5, and when we square that, we get a positive 25. So x minus 4 equals 25. Our possible solution is 29, which when we check it, we do not. We get 40 is equal to 0. That's false. No solution. Okay, now we're going to go ahead, we're going to dive into the quadratic example. So please write this example down, and you'll note that right away, the first step of isolating the radical is already done for us. I have the square root of 10 minus 3x. So I'm just going to jump right into squaring both sides. The square and the square root cancel. And what we get is 10 minus 3x is equal to x squared. Now at this stage, you should note that this is quadratic. How do I know it's quadratic? Well, it has a power of 2. Power of 2. Now, how do I solve a quadratic? How do I solve? You're going to move everything to one side. Move everything to one side. And then you're going to factor and solve, okay? So what side do I move everything to? Am I going to move that x squared over here with the other terms? No, actually I'm going to shift the 10 and the 3x over to the other side. I'm going to subtract 10, I'm going to add 3x, and I'm moving it over to this side. So the reason why I do this, the reason why I'm making my left side 0 is because I want my x squared term to be positive. X squared must be positive. Okay, that's mama. You want to keep mama happy. If mama ain't happy, nobody's happy. Keep x squared positive. Okay, so now I can go ahead and factor this, and I'm just going to use the AC method just like we did in our prior knowledge. X plus 5, x minus 2. Again, if you're concerned about how we got that, we just did what factors of negative 10 give us a positive 3. Okay, and then I'm going to set each of these equal to 0. So x minus 5 equals 0, x minus 2 equals 0. Subtract 5, and you get a possible solution of x equals negative 5. Add 2 to both sides, and we get a possible solution of x equals 2. Now, I need to check these. I'm going to go ahead and plug them in. And again, I'm going to check each one, but I'm going to plug them into the left side only. So the square root of 10 minus 3 times x, in this case, is negative 5. So we get 10 plus 15, that's 25. And the square root of 25 is 5. Okay, what's our right side? X. Well, in this case, our x was negative 5. So 5 is equal to negative 5. This is false. This is extraneous. Cross that out. Not an answer for x equals negative 5. Okay, how about for x equals 2? I'm going to check this. Square root of 10 minus 3 times 2. This gives us square root of 10 minus 6, which is the square root of 4, which is 2. And does 2 equal x? Well, x in this case is 2. Yep, this is valid. There you go. Not too bad. Not too bad. Okay, I would like you to practice this structure. Here is an example. Pause me. Go ahead, try this example, and we'll see what you get. I'll show you the answer here in a second. Okay, hopefully you try that one. You should have gotten 2 answers, -1 and 6 as possible solutions. When you check -1, you get a false statement. Okay, a square root can never equal a negative value. So that one's false. Throw that out, and then 6 is your final answer. This factorization, I'll say this about this factorization here, is that this one's tricky. This one's tricky because the 5 and the 6, sometimes people think 3 and the 2. So you really have to make sure, hey, when I multiply these, do I get a negative 6? When I add them, do I get a negative 5? Okay, here's another practice problem. Try this example. I'll show you the answer here in a second. All right, here is the solution. This one has a double solution. What? Both can work? Yes. You can have two answers. Square both sides. X squared is equal to x squared minus 6x plus 8 equals 0. Factor, and then you get your two solutions, 4 and 2. Okay, I believe this is the last example for this lesson. And here we're going to see the quadratic structure, but again, here I have step 1. I need to isolate that square root. So I'm just going to move that 2 over to the other side. Just going to move that to the other side, and we get square root of x plus 10 is equal to x minus 2. Okay, and then now I'm going to go ahead and square each side. Square each side in order to cancel out that square root, and we get x plus 10 is equal to x minus 2 squared. Watch out, don't take the shortcut here. X minus 2 squared is not, I repeat, is not x squared minus 4. It is not x squared plus 4. You have to distribute this out. You have to use FOIL. I'm going to go ahead and multiply this x to give me x squared, this x to give me negative 2x. I'm going to multiply this negative 2 times x, and then this negative 2 to give me positive 4. Right? So FOIL that out. You get x squared minus 4x plus 4 is equal to x plus 10. And then now we can go ahead and move our terms in order to create a quadratic that we can factor. So where am I going to move everything? Well, I want to keep the x squared positive, so I'm going to subtract x on this side. That cancels. Okay. And I'm going to subtract 10 over here. That cancels. And we get 0 is equal to x squared minus 5x minus 6. Hey, that pesky one again. All right, so we're going to go ahead and factor this. So 0 is equal to x. What factors of negative 6 give us negative 5? It's going to be minus 6 plus 1. And then our solution is x equals 6, x equals negative 1. So those are our possible solutions. We do need to go ahead and check them. I'm going to check it and see if it gives me a valid or extraneous. So let's go ahead and do that. Square root of 6 plus 10 plus 2, that's the square root of 16. That gives us 4 plus 2. Does that equal our right side, which is 6? Yep, it does. So 6 is valid. Valid. Okay, and then I'll check x equals negative 1. Square root of negative 1 plus 10 plus 2. What does that equal? Well, square root of 9 plus 2, that's 3 plus 2, that's 5. Is 5 equal to negative 1? Nope. So this is extraneous. Throw it away. Not valid. Okay. I do have a couple practice problems. Please pause video, try this one, go ahead and solve, and we'll see what you get. All right, hopefully you tried that. Here is the solution. You should have gotten x equals 1 and x equals negative 2, where the negative 2 is extraneous. Add 1. Double check. Did you square this? Did you do x plus 1 times x plus 1? To give you x squared plus 2x plus 1. And then did you move everything over to the right side and factor to get x plus 2, x minus 1? Okay. All right. Next example. Here you go. Please go ahead, pause me, see if you get this solution. All right. Hopefully now you're not fooled by squaring both sides with that x minus 4. X minus 4 times x minus 4. You get x plus 8 is equal to x squared minus 8x plus 16. We'll move everything over to the right side to keep that x squared positive. We'll factor to get x minus 1, x minus 8, and our solutions are 1 and 8. Okay, the x equals 1 is extraneous, so we crossed out the extraneous solution, and we get x is equal to 8. Alright, that's going to do it for this video. Hopefully in this video you learned how to solve square root equations that were more complex, where we had to do more heavy lifting once we got rid of the square root. And hopefully you can identify a square root as well as identify if its solution is valid or extraneous. Go ahead, like, subscribe. I'll catch you in the next video. Peace.